Hey guys, welcome back. Today we're going to do a short tutorial on how to determine molecular geometry of a molecule or ion. All right, we're going to go through four basic, easy to follow steps, and we are going to determine the molecular geometry of this guy today, CO2, aka carbon dioxide. All right, so step number one, you have to draw the Lewis structure of whatever the molecule or ion is. All right, so let's quickly. Okay, there we go. We've got our basic Lewis structure for CO2. Carbon is our central atom. It's in the center. And then we have oxygen on either side, double bonded to the carbon in the center. All right. If you're wondering about how do I determine if it's single, double, or triple bond, you need to keep in mind the number of valence electrons and remember that octet rule. Okay. Elements like to have a nice number of 8 valence electrons. So that will help you to kind of determine single, double, or triple. All right, so that's step one. Step two, we need to count the number of electron domains. All right, and to do that, we need to count the number of electron pairs around the center atom. All right, so if we go back to CO2, right, and we look at the center, which is carbon, we only have 2 regions where we're going to have electrons. Okay, and that's going to be right in between the oxygen. All right, so we have double bonds. That's going to be what? 2 pairs of electrons. So 2 on one side, 2 on the other. 2 plus 2 is 4. Oh, so we have a total of 4 electron domains. No, you don't. Okay, so the general rule is if you have a double or triple bond like we do here, okay, so we have a double bond, you count them as 1. Even though that there's 4 electron pairs there, okay, so like that that one line, that's going to be 2, that demonstrates that there's 2 electrons there, and then this one means that there's 2 there. Okay, even though there's total 2 pairs, we're going to count this as 1. Okay, and that's just the general rule. Double and triple counted as 1. Right, and then this one over here, we're going to count this as another one, so that makes our second. Okay, all right, so in this example, we only have 2 electron domains. Okay, so remember, keep in mind double and triple bonds, you count them as 1. All right, so our step 2, determine the number of electron domains. Step number 3, we have to determine the electron domain geometry. Oh my gosh, there's another geometry. What? That's okay. We're going to use a nice table, and that will become our best friend. All right, and this table is numbered 9.2. The digital version is on Canvas that you guys can access, and you guys will be given a paper copy to keep with you in your binder and in a safe place. Trust me, that will bail you out in chemistry when you get there. Okay, and that way you've got that. So you have a digital and a hand physical copy of it. All right, so what we're going to do is we're going to go back and refer to that table, our best friend 9.2. All right, the first column says number of electron domains. Well, we have 2. So we just need to find number 2. Oh, guess what? It's the first row. Oh, that's easy already. All right, so 2. And we go to the next column that says electron domain geometry. Wow, couldn't get that easier, could it? All right, and if we do that, we're going to get linear. Okay, and then I will say electron domain geometry. All right, so that way we know, okay, what this linear means. All right, that's step number 3. We have one more step. Step number 4, we need to determine the molecular geometry. So as you're looking at table 9.2-9.3, because they've split it up, all right, you're going to notice that when you look at the molecular geometries, there's going to be different ones for certain electron domain geometries. So how do we determine which one is going to be the correct one? Okay, so with step number 4, we're going to have like a little sub-step, so A, so to speak. We need to count the number of bonding electron pairs slash electron domains. Okay, and when we do this, we got to look at our center atom again, and that's going to be carbon. Okay, and we got to look at what's being bonded to it. So guess what? We have this over here that's bonding, and this over here is bonding together. All right, so to remember, okay, that rule from earlier, double bonds and triple bonds count as one. Do not count them as two pairs. Those just count it as one. All right, so in our case of CO2, we have two bonding domains, we'll say. Okay, so we have two bonding domains within CO2. All right, we're going to go back to our handy dandy table 9.2, aka our best friend, and we're going to go down where it says bonding domains, and we're going to find number 2. All right, and when we do that, it's going to tell us that our molecular geometry for CO2 is going to be linear. Okay, and again, just got that straight from table 9.2. There you go. We've determined the molecular geometry of CO2 in 4 easy peasy steps with the help of our best friend, table 9.2. All right. Some of you might be noticing, well, looky here, our electron geometry was linear. Our molecular geometry is linear. Can we just stop right there, like step 3, and be done with it? We could, but no, we can't. As you guys look at table 9.2/9.3, you're going to notice that for some of your electron domain geometries, there's going to be other molecular geometries attached to that. And again, that's just determinant upon how many bonding domains that we have around that central atom. Okay, so sometimes you may see where the electron geometry is going to be the exact same thing as the molecular geometry. Other times, this geometry is going to be very different from this one. Okay, and again, if we just look at our structure here, it looks linear. So that's kind of our visual to say, hey, that shape actually goes along with what we're seeing. Okay. All right, guys, that's how we determine molecular geometry in 4 easy steps with our best friend, table 9.2. All right, so guys, if you are still having problems or questions about this, please let me know. Okay, up on Canvas, you guys have a little exercise to do, and you will notice that there is an answer key. Don't get too excited. Your answer key is modified, so I've given you detailed answers for the odd ones only, but not the even ones. Okay, so as you guys are working through, look at the odd ones. If you're having problems, look at your answer key that's been provided. And if you're still getting stuck, please, please come see me. Please, please ask questions. Okay, otherwise, if you don't, I'm going to assume that you know it and we're going to move on. All right. Okay, guys, that's it in a nutshell. See you in class.